and welcome back to another tutorial. And in this tutorial, we are going to study about the quadratic inequalities. We'll study both the quadratic inequalities and we'll study uh, the linear inequalities as well. The question number one in front of us is a linear inequality that is 7b plus 3 is greater than to 6, right? In this type of inequalities where the power of p is just 1, we can call it linear inequalities, and we should treat this inequality just like an equation. We should try to solve this inequality just like a normal algebraic equation, in all the rules which are applied in algebra. All the rules of algebra are also applied here. So if something is positive on one side of the inequality, on the other side, when you move it, it will be negative. Plus 3 is here. So when you move it to the other side of the inequality, so this will give you is 7b is greater than 6 minus 3. Just like in algebra, when you move one item from one side of the equation to other, so the sign changes in the same way. Now the b is greater than 6 minus 3 is 3, and 3 over 7, because the 7 was multiplying on this side of the inequality, so when it moves to other side of the inequality, it will divide. So b is greater than 3 over 7. Or if you write in a fraction, you can also just divide this 3 with the 7, and you put a point and it becomes 30. 7 fours are 28, and then you get 2, and then you can put again one more 0. 7 twos are 14, and so on, 0.42, or b is greater than 0.42. So if you want to plot this inequality on a number line, so it will be like you draw a number line, and here it's 0, 1, 2, 3, and here it's a -1 and -2, so on. So here this b is greater than 0.42. So for example, if this point is 0.42, 0.42, so b is greater. So when it is only greater, you can just draw a number line like this and put a circle, and this one is called exclusive exclusive inequality, in which 0.42 is not included. So when 0.42 is not included, you have to represent it by a hollow circle. And if it's like b is greater than or equal to 0.42, in this case, this is called inclusive, and in this type of inequality, b is greater than or equal. It includes 0.42. In that case, you will just put up inclusive kind of inequality. You'll put here a solid circle or a dot and put an arrow on the right side towards which is it applies, or on the side where it's true. So b is greater, so b is here the greater than 0.42. So this is how you can solve the linear inequalities. And in the question number 2, it says solve a linear inequality with unknown on both sides. So in this inequality, we have got the unknowns 10a and 7a. these two unknowns on both the sides of inequality. And here we can see the sign shows that this is a inclusive. This is an inclusive inequality. So the rules remain the same. First, we need this variable, the unknown variable a, to be isolated and put everything else to other side of the equation. Isolate this variable and try to bring the smaller variable to the bigger side. So now here we have got 10a and here we have got 7a. So we should bring the variable, unknown variable, the smaller one towards bigger side because we want this a to be in positive. It should be a positive. If we take this a 10a to this side of the inequality, so we'll get our result will get negative 3a. So we do not want a negative sign with the a. Otherwise, we have to later uh, change this inequality sign. So rather to change the inequality sign, it's easier for us to just simply bring this a to this side and take this 10 to this side. So this is how it will look like. This is equal to uh, 10 plus 7. So this negative 10, when it goes to other side of the inequality, it will be positive 10 plus 7 is smaller than or equal. We write the same inequality sign and then we leave the 10a here and we write negative 7a, because this positive 7a, when comes to this side of the inequality, it becomes negative 7a. So now 10 plus 7 is 17, smaller than or equal to 10a minus 3a gives us 7a gives us 3a. And now we can solve this inequality. A is greater than or equal to 17 over 3, and then again it gives us a is greater than or equal to, if we divide this 17 with 3, 3 fives are 15 and 16 17 and 2 is carried, and 3 6 are 18, so 5.6. So a is greater than 5.6 and this greater than or equal to. So if we have to draw this one, so this is 3 4 5, this one. So 3 4 5 6, and we call this point is 5.6. So here it will be a solid line and this one like this. So a is greater than 5, 5.6. We write here 5 and this point we call it 5.6. So greater than or equal to. So in this case, this 5.6 is included. It's an inclusive inequality. So a is greater than or it's equal as well. So now we try to solve another kind of inequality, and in which two equalities are combined. Okay, so here we have got one equality: 7 is smaller than or equal to 2x minus 14, and the next inequality we have is 2x minus 14 is smaller than or equal to 23. In this type of inequalities, you have got two options to solve. Either you can solve in the same way as these are, and or you can separate them together, separate these two inequalities, solve them first, and at the end you can just combine them together. So if uh, if you solve in the same position without separating them, it's a little difficult or it's a little complicated. But if for those who are very advanced in their mathematics, they can solve it without making them separate. So I'll show you both the ways. So the first way is keeping all these in its own place. So what we have to do is in between these two equality signs, we have to leave only the variable here. The variable x we need to leave and take everything else to other side of the inequalities. So we have to remove this negative 14 from here, and we have to remove this 2 from here and isolate this x in between these two inequality signs. So this is how we are going to solve it. So first what we do is we'll simply take this negative 14 to both sides of inequalities, because this negative 14 is being impacted by this inequality and this inequality. So this is how we are going to solve this inequality. So we move this negative 14 to this side of inequality. So this becomes positive 14. 14 plus 7 is smaller than or equal to 2x, and 2x is smaller than or equal to 23 plus 14, right? So this negative 14, once we move to this side of the inequality as well as move to this side of the inequality, we move it to both sides of inequality because it is being impacted by, it has a relationship with both the inequalities. So now we solve this 14 plus 21 is smaller than or equal to 2x, and it is smaller than equal to 4, and 3 is 7, and 2 and 1 is 337. So in the next step what we do is we move this 2 to both sides of the inequality. If it's multiplying with the x, when it moves to other sides of the inequality, it will simply divide. So our the next inequality, the final would be 21 over 2 is smaller than or equal to x, and x is smaller than equal to 37 over 2. So you can leave this in the same situation, or you can write in points as well, in decimals as well. So we have almost arrived at our final solution where we have isolated the x in the middle, and then we have left both of these inequalities, the numbers to other sides. So if we move this to both sides, divide it, so two ones are two tens are 20 point, two fives are 10 is smaller than equal to x, and x is smaller than equal to two ones are 2, and 1 is carried out, two eights are 16, 18.5. So our inequality is from 10.5 to 18.5. So on the both sides, it is inclusive. So if we are going to draw this inequality, so here is 10.5 and here is 18.5, and our inequality is like this. We can draw it like this. So this is our inequality drawn on the number line. Now we move to the next inequality, and here we have got a quadratic inequality. So the quadratic inequality is the inequality in which we have a square, or on the power of x is not 1. So the power of x is square. So that is how we call a quadratic inequality. So how to first solve the quadratic inequality? So the procedure is the same. First, we have to factorize this quadratic equation just like a normal quadratic equation, right? So if we have to factorize it, so it's x squared minus 12x plus 35 is equal to 0. And now, when we solve this type of quadratic equation, what we do is we factorize it. Now, we need two factors. When we multiply them together, those two factors, it should give us, when you multiply those two factors, it should give us 35. And when we add them together, it should give us negative 12. So this should be our result. We need to find two factors. When we multiply them together, those two factors, it should give us 35. And when we add them together, it should give us a negative 12. Right? So 35, the factors are 1 and 35. 1 and 35 does not work. They do not make up negative 12. Then what we go for the next is 2 is not divisible, so 2 is not a factor. Then we go for the 3, right? 3 is also not a factor. Then we go to 5, and 5 sevens are 35. So 7 and 5 can make up 12 as well. So these 7 and 5, 7 times 5 are 35, and 7 plus 5 is also 7 plus 5 is also 12, right? So what we can do is here that those two factors are negative 7 and negative 5, because negative 7 and negative 5 will make a positive 35, and negative 7 and negative 5, if we add them together, it will give us a negative 12 result. So our two factors are these ones. So now how we are going to solve is we write x square, and then we write these two factors, uh, negative 7x negative 5x plus 35 is equal to 0. And then we take the common outside. So out of these two factors we take a common, and out of these two factors we take a common. So here x is in these both of these two factors, so we take x common outside, and inside we are left with x here, because x times x is x square, minus here x we have taken outside the bracket, so inside only 7 is left, and minus. Now, out of these two terms, we see here 5 is the common in both the terms. So if we take 5 outside, so inside x is left, and here uh, 35. So 5 sevens are 35. We write negative 7, because negative 7 times negative 7 gives us the positive 7. We need a positive 7 here, because negative negative gives us positive. So negative 7 and is equal to 0. Right now we can write, now again we take x minus 7 here, x minus 7 here. Both of these we take it common outside. X minus 7, x minus 7, not 5, x minus 7 we take common outside, and inside we are left with x minus 7. This term we have taken outside, so we are left with x here, and out of this old term x minus 7 we have taken outside, so we are left with x minus 5 in all. So now we put x minus 7 is equal to 0, and x minus 5 is equal to 0, and x is equal to 7, and x is equal to 5. So this is just like a normal equation, a quadratic equation, and we have tried to find the roots of x here. So now you have to look for this inequality, that here it says this inequality, this equation is greater than 0. So what you can do is you can just simply draw a graph here, and this means that the value, the x is equal to 7 and x is equal to 5. These are basically the points where the quadratic equation is crossing x-axis. So this is the place, for example, if this is the 5 and this is 7 here. So it says that x is uh, greater than or equal to. So what you have to do is you have to just draw an inequality like this. Okay, so when you draw an inequality, you can see on the 5 side, this quadratic graph, it goes towards left. From 5 onwards, it goes towards left. On the left side, this graph will move more and more left and goes on. On the right side, it moves towards positive direction. On this side, from the 7 onwards, this inequality goes towards positive side. So on the positive side, it's increasing. It's always increasing. So this inequality you can write is x is here smaller than 5. X is smaller than 5 because it's decreasing from the 5 and going towards more and more smaller side. So the biggest point is x is 5 here, equal to, or x is smaller or equal to 5. So smaller or equal to 5. And then here on the right side, x is greater or equal to x is greater than or equal to 7. So when it's greater, we have to always here, when we see this sign, it's a greater sign here. When it's a greater, we have to look for the values above this 0 on the y-axis, right? So the above is this portion. We are concerned about this portion of the graph. We are concerned about this portion of the graph. So we are only concerned about above this 0 line, not below this line, below this 0 on the y-axis. We are only concerned about the part of the inequality that is represented above this line. So if this is a graph x and y axis coordinates, and if this is 5 and this is 7 on the x axis, so we have to look for this inequality. If it's greater, then we are concerned about this portion of the graph only. And if we look at this portion of the graph, here it's a 7, so from 7 it's increasing, and here it's a 5. From 5 it's decreasing. So the x is smaller than or equal to 5 because this graph goes, you see here, it's goes decreasing, smaller, 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 more and more smaller. So x is smaller than 5, and on this side, this graph is, this line is increasing, increasing, increasing towards right side. So x is greater than 7. So these two are our answers. So x is smaller than or equal to 5, or x is greater than or equal to 7. So these two should be our answers for this question.